In this lesson we're going to look at simultaneous equations, but slightly more difficult than the last lesson. So let's look at these two equations here. Solve this pair of equations. 5y plus 4x is 13, 3y take away x is equal to 1. So what we were doing before is we were adding the two equations together, and what we found is the y's would cancel out or the x's would cancel each other out, and that helped us solve the first part. Now if you look at these simultaneous equations, if we add them together, you get 5y and 3y, that would give you 8y, so they wouldn't cancel. And you would get 4x add negative x would give you 3x, and that wouldn't cancel either, so there's a bit of an issue there. This is why this is a wee bit more difficult than the last one. Now the reason the last one's cancelled out is because there was a plus and a minus of the same value. So in this case, if we look at the plus 4x, there would be a minus 4x, so when you added them together you would get a cancellation happening. Now this is not happening if we add these two as they are just now, but there's something we can do to make this bottom equation, i.e. equation 2, into a 4x. What you have to do is basically multiply both of the sides of the equation up by 4. So you're not changing the values in the equation, if you like, you're just changing the size of each side of it. So 3y multiplied by 4 is going to give you 12y. Negative x multiplied by 4 is negative 4x. And 1 times 4 is 4. What we tend to do is we call this equation 3 because it's a new equation. And then we want to deal with this top equation and this bottom one here. So we bring the top one down below and rewrite it. And we call that equation 4. That's just taking the 5y and the 4x and the 13 and rewriting it again. Now if you look at these new equations, what you can see is we've got a minus 4x and a plus 4x. And that's kind of what we're looking for when we're adding the two equations together. If you add the new equations 3 and 4 together, what happens is when you add the 12 and the 5 you get 17y's. But when you add the negative 4x and the plus 4x, you get 0, the x's disappear. And when you add the 4 and the 13, you get 17. Now we can solve it for y. If you divide both sides by 17, you get y is equal to 1. Now, to get the x value, you can just do as we did before. You can substitute the 1 into either equations. I'm going to go with the second one here because it looks quite a simple one to deal with. However, you could go with the top one. So if we sub into equation 2, 3y means 3 lots of y, in this case 1, so 3 times 1 is just 3, and you take away the x and you've got equals 1. And the easiest way to do this is 3 take away what makes 1, well it's 2 isn't it? So there's your answer 2. So the solution is x equals 2 and y equals 1. Remember, if you were to draw these two lines on a graph, you would get a point of intersection, and that would happen at 2, 1. Now just finally we can check the values in equation, well any of these equations you can check it in 1, 3 or 4, but we'll just check it in 1. 5y plus 4x equals 13. So we're saying that x is 2 and y is 1. So if y is 1, 5 lots of y equals 5. And if x is 2, 4 2s are 8. Well, 5 add 8 equals 13. That's great, it works.